Hello and welcome back to a new video. I'm Tej, your host, where today I'm going to show you how to take your Arduino projects to the next level and make them look professional. And well, the elevation and professionalism can be found by the use of custom PCBs. And that is exactly what I'll walk you through today, with all the steps and everything you need to know to make your first PCB. And don't worry, you don't need to be like some experienced electronic engineer or basically in the engineering field, because this process is actually much easier than you think it is. So let's start and make our first PCB. This video is also sponsored by the amazing and reliable service of JLCPCB, but more on them later. So let's face it, even the simplest projects can look like a mess if it's all wired up like this. People might label it as too complicated or even like a potential fire hazard. So I'm going to show you how to turn something like this into a sleek, polished, and safe design like this. So firstly, in order to actually make something like that, we first need to understand what it is and how it works. So a printed circuit board, also known as PCB, is a flat board made of non-conductive material with conductive copper traces and pads on its surface. It serves as a foundation for mounting and connecting electronic components in a systematic and reliable manner. So basically like this. So what's happening is that there's components inside of the PCB going through it, like this piezo buzzer and this LED. Now, these PCBs come in various types and sizes, ranging from single layer to multi-layer boards. Now, these boards right here are double layers, and that is like the most common PCB ever made, just 2-layer PCBs. Now, there's traces on the PCB that act as pathways to carry electrical signals between components, forming complete circuits. So if you'll see right here in perfect flashlight condition, these are the traces. And basically, these are basically wires that are connecting through, and they're also on the back. So now you may ask, what are the steps to actually creating a PCB? And well, it's actually not as complicated as you think it is. So the first step to creating a PCB is to design the circuit schematic and then converting it into a PCB layout, which then creating a Gerber file. Gerber or Gerber, I don't know how to pronounce that. Not sure, but I think it's Gerber. Then you send it to a PCB manufacturer like JLCPCB, my personal favorite, and then apply solder to the parts of the PCB. But seriously, PCBs have revolutionized modern electronics, enabling the creation of efficient and sophisticated electronic devices. And these PCBs can be found in your TV remote, microwave, or literally any other device. And you can even see that these have advanced over the time, as if you look at like an older phone, it was like quite thick, and those were the parts inside. But now if you look at the latest phones, you'll see that how thin they are, yet they're more so powerful. So everything advances, even the PCBs. Now let's dive into the basic 3 parts of the PCB. So firstly, you got 2 ways to attach components. Surface mount, where you place components on top of copper pads, and then through holes, where you insert the component leads through the board and solder them from below. If you're new to PCBs and soldering, the through hole method is the way to go, as the components are larger and easier to handle. So in this situation also, I've actually used a through hole technique where the piezo buzzer actually went through the hole in the PCB, and then I solder it from the back. Now let's actually check out some real PCBs today and what we'll be actually making in this video. So let me just explain the basic overview of what we'll do to create it. So for PCB design, we'll use JLCPCB, an amazing online service with a quick response and servicing. It provides best PCBs with lower costs that are $2 for 5 PCBs. And then for the PCB file generation, we will use the Easy EDA software online. So this is an example of the PCBs that are created and the components attached to it. And basically, this is kind of like the design that we'll create. So basically, there's an ultrasonic sensor on the forward and the back. Basically, I wanted to include many sensors all in this, and then that actually eliminates like more than 70% of the wires just going all over the place. So basically, here's a connection of all the sensors all in one place. So firstly, you can use Easy EDA to create the PCB and sign in. Okay. So we're gonna click on new project, and let's name this Arduino Sensor PCB. And there you go, we are into the workspace. This almost feels like AutoCAD, but it is not. So you can use the middle mouse button to move around, and right mouse button as well, which is this one. And basically you can select with the left mouse. So what we'll be creating today is pretty similar to the idea of here right now. So basically there's an Arduino we're gonna use, and there's gonna be some sensors like, let's use ultrasonic sensors for this one. And let's use a PIR sensor, why not? So Easy EDA pretty much has all the components you need already inside of it. And basically to get that, you simply click on library right here. And then here you'll see all these parts. And basically under classes is where you're gonna get all those components. So you can click here. So what we're needing is an Arduino Uno. Let's search that. And basically you'll see this. So these are Arduino Nano, and I don't even know what this is. So basically what you can do is you can look at these, and most likely you are going to find these components under user contributed. That is where 99% of all the components are used. So basically these are all the parts of the Arduino Uno by separate other creators. Okay, so I am looking at this picture. You can click on this picture and it will show you the actual components. And yeah, this one actually seems quite good because you can see there's digital pin 1, 2, 3, 4, and so on. So basically go to library and let's click here and let's press place. So there you go, let's place and right click to deselect the other parts. And you can press this to move the circuit around. And yeah, now our Arduino Uno is in place. So let's go to library again and let's search for now ultrasonic sensor. And there you go. So let's click on one and let's see. VCC, perfect, trig, echo, ground, and here is how it will look like. And that is actually exactly how it looks like on the board as well, as you can see right here. Now, what I would prefer is place that, as that's quite accurate. And what else do we need? Let's look for a PIR sensor, PIR motion sensor module, perfect. There you go, that's very accurate to the real one. And now that you've placed all the components in the schematic, now what we need to do is make the connections. Now basically we can click on wiring right here and basically connect on here. So left click and let's place it on digital pin 3. There you go, simple as that. And then right click to cancel and basically do the same for all of them. Now here, the connections do not need to look nice because these are just for reference purpose of how it will be connected. So at this point right now, everything is rough. So here I'd actually like to label the wire, like which one it is what. So I'll here click VCC because that means basically +5. I'm going to tap it right here. So this actually shows me that this wire right here is connected to the VCC. So there you go. For the representation purpose, I've actually just connected the components real fast so that I can show it to you how to do things next. Holy, do not worry about the overlapping as like this wire overlaps with this one. It does not matter at this point. Now the reason for that is this is not how the PCB looks like in the final stage. The computer will actually automatically do that for you. So that's quite good. Okay, so now that you've done all the basic connections, now what you can do is click on design and convert schematic to PCB. Here you'll see a warning that there are some unfinished nets. Do you want to check the nets first? And this is very common and this will pretty much 90% will always come. So what you can simply do is just click yes, check nets. And nets is basically the reference made to the pins on the PCB. So it basically means that these pins right here, they're basically open and they're not connected to anything. So that's what is basically referring to as well, like the nets. So then, with that information, you do not actually need to click the yes, check nets. Click on no, keep going. And there you go. Oh, we need to save the file first. So yeah, let's save the file. So to save the file, you basically need to click here and that will save the file to the server. There you go, saved successfully. Now let's press design, convert schematic to PCB, and no, keep going. So over here, it's actually showing me there's a problem with the IR sensor. And actually in many of these cases, just delete the IR sensor part and select a different one from the library. Okay, so this IR sensor is actually giving me some problems. So I'll actually just delete it for this representation purpose. So I should delete these connections. But basically what you can do to fix such problem is basically just go to library and select a different part of these IR sensors. There's lots. So you just have to play with the settings a little bit. So there you go, these are all the default settings for the PCB and this is the official PCB and how it will look like. So basically just click here, apply as these are the default, and there you go. This is the area for the PCB, the purple area. So then what you can do is simply place the components inside. And then here you can also add text here, so let's just do that. And I'm gonna type here, say designed by Tej, because why not? You can put your name there. And there you go, that text is in and you can place it anywhere. So there you go, you can place it right there. And actually before doing that, you must actually label it as top silk layer, as this is actually just a silk layer, as this is not like the copper trace. And if you want it to be on the back side like this, Arduino Uno used, so that is a silk layer on the back. So make sure that this is always at top silk layer or bottom silk layer or any of these. So if you want some components such as a PIR to be on like the top or the bottom, you can click the layer and basically you can select as bottom layer. So it will basically send it to the bottom of the PCB. Okay, and here you can also do the labeling. So basically like label it as 5 volts, for example. 5 volts. So now here is the time to do routing of all the copper traces. Now what you need is the copper traces to actually move all around, because like if you look at here, this is really not clean, right? So these are the wire pieces. And now what you can do is simply click on route and click on auto route, and this will automatically do that for you. So let's click on run and you can see the magic. And there you go, attempted 39, completed 39, failed 0, and total via 0. So completion is 100%, and you can see at that. Now that is amazing. Look at it, automatically routed everything for you. Now that everything is in order and you can see the connections are proper, now what you can do is simply click on file and press save. And now that you need to actually get them printed and have it in your hand, now you need a Gerber file, and that is what we need to send to the manufacturer. Now this Gerber file is basically the list of how to actually create this PCB. So what you can simply do is click on fabrication and click on this PCB fabrication file Gerber, and that's what you're looking for. So now it's basically telling you to check the design again. So I mean, most likely it is a good idea to do that. So click on yes, check DRC. So it's basically design rule checking, and there you go, that's what it will look like. And then you click on generate Gerber, and there you go. It will actually download that for you, so let's do that. So now that we have that, let's actually go on over to the JLCPCB website, and there you'll see the best prices as well. So here, click on order now, and there you go. Over there saying add Gerber file, and basically we're going under standard PCB and click on add Gerber. So it's gonna upload the file automatically. And here, while that is uploading, we can click whether you need 1 layer or 2 layers. I would prefer it simply just to be at 2 layers because that's the most common one. And there are lots of coupons that they give, so you can click on that, and there you go, you just got a free coupon as well. So here you can also click on the shipping methods, which you can use. And then from there, you can simply click on next. So here it's going to show the top and the bottom. So you can click on next. So here they also ask the BOM file and the CPL file. And basically you can find the BOM file and the CPL file also in here, which is under fabrication as well. And that's what you need. And actually before you submit the order, they will actually check if there's any design flaws or any major problems with your design. And they will contact you very fast. So let's order and wait for it now.
Several days later.
Here we go. I actually got the notification the package is here. Let's go check it out. This is very exciting. Alright, good. Alright, so here it is. JLCPCB. The PCBs are here and they're super packed. Wow. Look at that. Look how clean that is. Alright, so here, I currently do not have the header pin, so I can't really connect it like that. Then once your PCBs arrive, it's time to start soldering. Okay, so as you can see that I soldered on the piezo buzzer on the PCB, and there you go, that actually looks amazing. So I can move it and it won't fall. That's the power of soldering. So I'll also show you how to basically add these components as well, like the LED, and basically solder this onto the PCB. So let's do that. So the best way to do it is basically the technique of through hole. So basically what you do is you take the component and you basically just put it through the hole and make sure that it's matching the schematic. Just like that, so that I'm actually referring to that as well. But make sure the positive and negative and all that's correct. Just that's all. And after that, you'll see this excess, and basically you can trim that with a knife or basically any other tool you got. And it's simple as that. Okay, so right here, I've connected the Arduino to the PCB plate, which is connected to the piezo buzzer. I'm doing this just to make sure that the thing is working, and that'll be proved by the sound of this. And I've written here the code for that. Piezo buzzer connected through the PCB to the Arduino through these 4 wires. Okay, let's send, and oh, it's working. Yes, let's go. That means the wiring and then everything is pretty much correct. So here's like the final wiring. So I did not have the header pins. That means I connected it through the wires. So that's why it's like that. Use what you got, right? And voila, you've turned your hacked together DIY project into a professional looking masterpiece. Now if you enjoyed this video, please consider subscribing as it helps the channel a lot. If you watched the video till the end and would like to tell me that you watched it and learned something new, comment down below to why PCB, and it would mean a lot. And if you'd like to know more Arduino myths, you can click here to watch that video. They're the myths busted for the Arduino, like there. And until then.